Now we're going to look at a type of equation I call an exponential quadratic equation. So let's say that you were given an equation that looked like this and asked to solve for x. Now, it might not be immediately obvious, but there's an exponential expression of 2 to the power of x being repeated twice here, once in the middle, which is clear to see, and once here. It's easier to see that if we rewrite the first term as 2 to the power of x squared. And we can do that because by the exponent rules, when you raise a power to a power, you multiply them together. So 2 to the power of x squared would be 2 to the power of 2x. We're going to rewrite the rest of the equation just as it was above. Now, we've got a pattern where we have something squared minus 6 times something plus 8. That's actually a quadratic pattern, and it's easier to see that if we replace the 2 to the power of x with another variable. We're going to use a. So let 2 to the power of x be equal to a. Then we get a squared, replacing this 2 to the power of x with a, minus 6a, replacing this 2 to the power of x with a, plus 8 is equal to 0. And we can solve that quadratic by factoring. And in order for the left side to be equal to 0, either the left bracket or the right bracket has to be equal to 0. So either a is equal to 4 or a is equal to 2. Now, we weren't trying to solve for a, though. We introduced that variable. We were trying to solve for x. So we need to substitute back. So 2 to the power of x is equal to a, so we put 2 to the power of x back in for a. 2 to the power of x is equal to 4. That means x is equal to 2. That's one of our solutions. And similarly here, we replace a back with 2 to the power of x, so 2 to the power of x is equal to 2. That means x is equal to 1. So our two solutions are x is equal to 2 or x is equal to 1, and we could check both of those by plugging them back into the original expression. So the original equation, excuse me. So the basic idea here is to replace the exponential expression with another variable in order to make the quadratic pattern easier to see and then to solve. Let's do another example. This time, our exponential expression has a base of 3, and it looks like we have 3 to the power of 2x here, although in this case it's made a bit more complicated by this 1. So let's try a similar sort of thing. We're going to break 3 to the power of 2x plus 1 up into 3 to the power of 2x times 3 to the power of 1. Again, we're using the exponent rules because when you multiply two exponential expressions with the same base, you add the exponents. Here we're running that backwards. And again, we're going to rewrite the rest of the equation just as it appeared above. Now 3 to the power of 1 is just equal to 3, and I'm going to move that to the other side of this 3 to the power of 2x. And just like we did in the previous example, I'm going to write 3 to the power of 2x as 3x squared, and then rewrite the rest of the equation the same as it was. In this case, we're going to let 3 to the power of x be equal to a. Now we get 3a squared minus 10a plus 3 is equal to 0. And if we factor that, we get 3a minus 1 times a minus 3 is equal to 0. Well, that means either 3a minus 1 is equal to 0, in which case 3a is equal to 1, or a is equal to a third, or a minus 3 is equal to 0, or a is equal to 3. Now we're not done there, however. We need to sub 3x back in, so 3 to the power of x is equal to a third, and solving that exponential equation gives us x is equal to -1. So that's one of our solutions. Here, we replace a with 3 to the power of x again. We get 3 to the power of x is equal to 3, or x is equal to +1. So in this case, our two solutions are x is equal to -1 and x is equal to +1. And again, we can check that by plugging them back into the original equations. So that's how to solve this type of quadratic exponential or exponential quadratic equation.